So we're just going to take the opportunity to go over a specific kind of question. And this is one that I like to call an in terms of question. Those are three little words that you can easily identify when you're writing a test or exam, and you can apply this strategy in following it, in solving it. SOHCAHTOA and Pythagoras are combined, and you know both, so there's no reason to feel afraid when you see in terms of. Right, if tan 33 is equal to P, determine the following in terms of P. That means P must be in your answer. We're not looking for a whole value. We're not looking for numbers. We're looking for P and mathematical operations, plussing, minusing, square rooting if need be. And the way we can approach this is by sketching. So I've narrowed it down to two kinds of arrows. Sketch a triangle, because Pythagoras and SOHCAHTOA both rely on right-angled triangles. So we're going to use the information we've been given. Tan 33 is equal to P. So I'm going to draw a little triangle. Doesn't have to be accurate at all. You just label it as a right-angled triangle, and you label the one angle as 33 degrees. Now the very next logical step would be to find the size of that third angle. So I want you to get into that habit. It's easy peasy. You know all three angles of a triangle add up to 180. So this is obviously going to be 180 minus the 90 degrees minus that 33, which gives us 57 degrees in this corner of the triangle. As you can see, we might need it later. Right, we've got all three angles of the triangle labeled. And now we need to use Pythagoras to label all three sides. Remember, we have a hypotenuse in a right-angled triangle. And the only thing we can actually think about right now is that in terms of 33, or with respect to this reference angle of 33 degrees, don't you agree? We have opposite over here, adjacent down below over here. And the information we've been given is tan of 33 is equal to P. Remember, SOHCAHTOA tells us that tan is opposite over adjacent. So let's convert our P into fraction format by making it P over 1. And if we have P over 1 as opposite over adjacent, look at how I have labeled the two sides of this triangle with respect to the 33 degrees, of course, because that's what we've been given in our question. So we now have two of the three sides in a right-angled triangle. We can find the length of that third side by using the theorem of Pythagoras. So Pythag says that the hypotenuse squared, and something that I'd like you to just also get into a habit of is, if you want to look for variables, if we don't know the three sides of a triangle, always call the hypotenuse R, the vertical side of the triangle Y, and the horizontal side of the triangle X. That's just a nifty trio of variables that will be commonly seen, okay, or seen quite often. But if you ended up using the word hypotenuse squared, that's perfectly fine as well. The hypotenuse squared is equal to the sum of the squares of the other two sides. How do we know this? Because of dear Pythag. All right, so according to the theorem of Pythagoras, we can evaluate the hypotenuse by squaring the other two sides. So if I wanted hype all by itself, the hypotenuse all by itself, I would square root. My 1 squared is just 1 plus p squared. Please do not drop the squared symbol over here at the p. You can't cancel out a square by square rooting if there's more than one term underneath the square root symbol. So here we have in terms of p, an expression for the hypotenuse. 1 plus p squared. Let me go back to my little step-by-step, don't forget arrow process. First was sketch the triangle and label all three angles, and next was use the theorem of Pythagoras to label all three sides of the triangle. Voila, we've done that, which means we are ready to answer these three questions. Determine the value of sine 33, cos 33, and tan 57. Here we go. Sine 33. Back to our good old SOHCAHTOA. Opposite over hypotenuse using 33 as the reference point. As we've labeled above, do you see our opposite? Remember, we take this as a little arrow, and if we were to shoot a bow and arrow, we'd cross that triangle, and our opposite would be the letter P. We don't need numbers because the question said have your answers in terms of P. And the hypotenuse, as we labeled earlier, is 1 plus p squared, all underneath a square root symbol. It could have been p squared plus 1 as well. We can add in any order, of course. Not so bad. Next one we have to do is cosine of 33. Cosine, according to SOHCAHTOA, is adjacent over hypotenuse, using 33 as our reference angle. 33, what's adjacent to it? It is a 1 over the hypotenuse, 1 plus p squared, all under the square root symbol. So there we've done cos 33. And last but not least, let me squeeze it onto the same page. Let's do tan of 57. Ooh, 57. Thank goodness we went and found our third angle of the triangle much earlier on. 57 degrees. SOHCAHTOA tells us tan is opposite over adjacent, but now we're using the 57 degree as the reference point. So let's be careful in identifying what lies opposite to the 57. Opposite the 57 is the number 1. And adjacent to the 57 is the P. So tan 57 in terms of P is equal to 1 over P. It's okay if you feel slightly uncomfortable with having these final answers. It is unusual, but according to the instructions, we have written these three trigonometric functions in terms of P. Let's see if you have what it takes to write the following in terms of K. If cos 25 is equal to K, follow those steps. Notice that I've given you a cos this time around, so we've given you a secret adjacent over hypotenuse. So once we sketch this, perhaps you should pause the video right now and only resume once you've done it yourself to check yourself. We're going to sketch 25 degrees, and because it's a good habit, I'm going to calculate this third angle of the triangle. Interior angles of a triangle all add up to 180, so I'm going to subtract my 90 degrees and my 25 degrees in order to get that third angle, which is of course 65 degrees. And since I have already labeled my sides, K over 1 is adjacent over hypotenuse with reference to the 25 degrees. So adjacent to 25 will be K. The hypotenuse this time is 1. And so the third side of the triangle that is dying to be found is this vertical side here. Vertical sides of triangles are often referred to with the variable of y. So I'm just going to go y squared plus k squared is equal to 1 squared. Remember that the hypotenuse squared is the sum of the squares of the other two sides. What am I going on about? The theorem of Pythagoras. So Pythag says y squared plus k squared is equal to 1 squared. The question wants our answers in terms of k. So this y squared needs to be replaced with k's. So I'm going to keep my 1 where it is, take the k squared over, square root both sides, and I get the vertical side of my triangle in terms of k, and that is now 1 minus k squared, or underneath the square root symbol. Jumping in to answer the questions. Sine 25, opposite over hypotenuse because of SOHCAHTOA. Opposite to 25 is our 1 minus k squared, and our hypotenuse is just a 1. So if you wrote your final answer without the 1 as the denominator, that would be correct. And then tan 65, opposite over adjacent according to SOHCAHTOA, but watch out, we're now taking the reference point as 65, so opposite to 65 is k, and adjacent to 65 is the side that is not the hypotenuse, 1 minus k squared. By this stage, you should be confident to answer the questions below this video embedded into this task, and that question is seen right here. So pause the clip, give it a go, and enter your answers below. Good luck. Thereafter, there's a challenge. Enjoy.